Hello, welcome once again to the class. And still on BECE Math, this time we are going to tackle angles. We are going to look at how to solve angle question. I'm going to break it down for you to understand how to solve what? The angle questions. Good. This topic has been one of the challenging topics for most students. But once you listen here, I bet you, I challenge you that we are going to break this thing down, give you all the tricks involved, so that when you see angle question, you can solve them and solve them very well. Good. So let's go straight into this. Straight into what? Into angles. Now, when we say angles, what are they? The moment two lines meet, an angle is formed. The moment two lines meet. Listen, once again, I always say this, you are now building your angles. In angles, always listen to the principle than the drawings. The drawing might not look like what you think, but the principle is still working. So listen to the principles and apply them than to focus on one drawing explanation and one drawing understand. So you understand this? No. Make sure you understand the principle. You understand the principle, no matter how the diagram is changed, you can do what? You can solve it. Okay, so an angle is formed. I said the moment two lines meet, this line meets that line, and what? And an angle is formed. So this corner is an angle, that corner is an angle, and this becomes a problem because therefore we all think that the angle should be corners. But I tell students that when a straight line meets another straight line, the definition says that when two lines meet, an angle must be formed. We never say it should be a corner. So if I've done this and I'm giving this to you, don't think that all angles should be corners. No, the angle is here and it's a straight line. So the angle is once again has been formed. So you see, I'm just trying to prove to you that when you listen to what we are saying, it benefits you more than looking at drawing. So maybe after doing or explaining what an angle is, two lines meeting, I did this as an example, then I did that. So you thought, okay, then this and this is proper. No. Now this is what you should know, that in this diagram or in this thing, the moment two lines meet, so if this straight line meets another straight line here, an angle must be formed. It's not corner. I hope you're getting that. Good. So we go straight into it. Now, these are the things we are going to look at. The first one we'll look at is angles that meet at a point to form what? To form a circle, or angles forming a circle. All the angles must meet at a point, of course. So we first of all look at angles that forms a circle. So angles forming a circle. Angles forming a circle. They are meeting at a point. Of course, angles must meet at a point. If there's no point, there's no angle. You understand? The moment they meet, they form a point. So angles forming a circle, one must meet what? At a point. So the angles must meet at a point. Good. So I have this guy here and that guy. So this angle, that angle, and that angle are meeting at a point. But their axis is forming a circle. This is what you do. This one most of you mix or miss. Now, we are saying that the angle must meet at a point. So we have the angles here. And also, their axis must complete a circle. That doesn't mean that you should do. If you have this arc, that arc, I don't just draw the hand. So once I can go around it, then I get what? A circle. Hence, the practice will work. That if this is A, that is B, and that is C, then A plus B plus C, since they are at a point, that's what the reality. The thing is that their axis can complete a circle. Total angle in the circle is 360. So therefore, we add this and get what? 360. Hope you get the point I'm making here. So anytime the angle is at a point, don't rush the angles at the point is 360. No. Do their axis complete a circle? If their arc complete a circle, then we can say the sum to 180. Once again, not the drawing. If I give you this, remember their angles. So if there are only two angles, if I have angle A and angle B, that are the angles meeting at a point? Of course they are. Will their axis complete a circle? Yes, when I trace it can complete a circle. Therefore, A plus B must also be equal to what? Must also be equal to 360. So it's not necessarily the diagram I've drawn, but I'm understanding what I've said there. How do you get this? Yeah, very, very simple. Very simple. In any drawing you have the angle, look for these guys. If you see angles meet at a point, try trace their axis. If the axis can give you a circle, this will work. If it can't, it will not work. Yes, some angles will meet at a point, but their axis will not complete a circle. Hence, you can't say that is 360. So you don't just say angles meet at a point to solve the 360. No. When they are meet at a point, the next condition is that will their angles complete a circle? If their angles are complete a circle, then if their axes are completing a circle, then that is true. So that's the first one. Then the next one is what? angles forming a straight line, or angles on a straight line. Angles on a straight line. So the next one, so this is the first thing, and this I'm touching on the principles. I'm not creating the topics of some things you need to know, so I can write the BC with them. So the next one is angles forming a straight line. Angles forming a straight line. So this time, what are the things? The angles once again must meet at a point. Then this time their arcs must give us half an angle. You get the point I'm making here? Half of the circle, their arcs will form a circle instead of a circle. I don't know if you get the point I'm making here. Yeah. So this is what I'm trying to say here. That for this one, these are the tricks here. For this one, we have this one here. Yes, they are meeting at a point. We have this, we have that, we have that. A, B, C. Yes, that is A, B, C, A, B, C. But if you look at the arcs, so you don't just say angles that are meeting at a point. When they meet at a point, this also meets at a point. But their arcs do not make a circle. We don't have this one. Their arcs make a semicircle. And that we add A plus B plus semi of a circle, half of it. A whole circle gives us 360. So half of it must give me 180. I hope you get the point I'm making here. Any straight line you see, once there are angles, don't look at the diagram. I have drawn this. In the diagram or in the question, I have this, and this will be the thing. Is this your straight line? Are they meeting at a point? Are there axes? Are the questions you ask yourself? Are there axes giving me a semicircle? So if this is x, y, and z, then x, y, plus z must be equal to 180 because their axe gives a semi half of a circle. But if the axe can complete a circle, like I've said here, then people, why not? Why not use that? I'll get the point I'm making here. Good. If there are only two angles on the line, I'm giving this, and there's a line here that's A and that is B. That is no problem. What is the criteria? That they should meet at a point. Checked. The axe must give a semicircle. Also checked. Then we have A plus B equals what? Equals 180. Okay, getting this. So anytime we have, and this thing when the angle is given to, once you see a straight line, see the angles on it. Once the angles there are all following this, it makes sense, right? And the third one is vertically opposite angles. The third one we are looking at is what? Vertically. So in this video, I'm going to summarize all the properties. Then I'll come back in the second video. Then I'll come to solve questions on the angles with you. Good. So here we're looking at what? Vertically opposite. So the third one, we have vertically opposite angles. We have vertically opposite angles. And vertically opposite angles, you always find them in an X symbol. Look into that, I've said that. They're always present in a symbol that, so anytime you see a diagram and the lines are crossing to give you an X, then vertical opposite will work. The angle here is equal to the angle there. The angle there is equal to the angle here. So if here is A and there is B, then from vertically opposite, A equals what? B. Very simple. How do I also know this? Don't mean this try to not work. I don't see any X symbol. I don't see any X symbol. But if a diagram is drawn for you this when you see this, this is an X symbol, then the angle here must work with the angle here. That's how we do angles. So don't forget the drawing and understand. Do the lines cross each other to give an X symbol, then that means that the angle and the angle is, if you look at this one, if you trace this one to get the same thing. I hope you get the point I'm making here. Yeah, so that is about vertically opposite angle. Very simple one. So we'll have, if here is C and there is B, then C is also equal to B. Simple. So in any diagram, when I'm solving the questions with you, I'll be pinpointing them that you see that we spoke of this, we spoke of that, this one we are doing, this one we are doing that. I'll get the point. Okay. Then let's go to the fourth one, which is what? The right angle. Once again, the angles are meeting. And you can apply this one here. You can apply both the angles meeting at a point or angles at a point. Here, you can see that the axe will give you 360. When we add A plus B plus C plus D, we should get 360. If we take this straight line, then the angle here, A and B, must sum up to what? To 180. If we take the same straight line, then this and this must sum up to, so that is how you play with it. So in this alone, I can have what? I can have angles on a straight line, the angles forming what? A circle. I can have that work. It will work. Also, my vertical opposite angles are also working. Then the fourth one, then I have the right angle. The right angle. And right angle, once again, they meet at a point, this point, but just that they will give us what? 90 degrees. They will give us quarter of what? Of the 360. That's why it's 90. So if you see what is going on, you see that we had the whole thing 360, half of it was what? 180. So quarter of it is what? It's 90. That means when I add A plus B, that should give me what? 90 degrees. And in this case, the question must always put the 90 there. The question don't have this symbol, you don't say it's 90. You can't say that unless they put it to indicate that these lines are what? Perpendicular. Then we can say boldly that A plus B should be equal to what? 90 degrees. So anytime you're solving a question and we have this corner and they put this one and this one is placed automatically, we do what? We go and solve it that way. I hope you get the point I'm making here. Hey, get a point? Okay. So let's go. So now we've done 4. Let's go to one of the major things that also disturb students, what we call the what? The properties of power lines. Properties of power lines. Let's see how we are going to get this one to properties of power lines. Please listen to this one very well. Properties of what? Of power lines. Properties of power lines. Now, this is a power line. That is another power line. So we put the arrows to indicate that they are going to the same direction. Now, the moment we draw a line here, we have what we call the transversal. We have what? A transversal. Very, very important. So this line here is called the what? The transversal. That's the line that divides them. Once again, the diagram doesn't matter. What I'm going to say about the diagram that matters. But these are the things we look out for. The arrows must be on the line. That indicates that they are parallel. If the arrows are not there, you can't tell. Because we can have anti-parallel lines too. The arrows might go in different direction. Yes, they don't meet, but they are going in different direction. Therefore, they are anti-parallel. But we are dealing with what? With parallel lines. How to get a point I'm making? So we have to see the arrow before we can work. Now we have A here. We have B there. Angle C. Then put D here. Angle E. Then put angle F. G and what? H. These are all angles, right? Now, before we even continue, let's look at this. You can see that the angle, if I take this straight line, then I can say this, when the sound is giving what? 180, this and 180. When I take this straight line, this and this, 180, that and that, 180. Just applying that. When I look at this and I take all the arcs, I can say all this should sum up to what? To 360. Vertically opposite. Do I see an X? Yes, I see an X. When I see an X, I also apply it. So it's very, very simple here. But under power lines, we are looking at 3 properties. So we call them the properties of power lines, and we are looking at 3. The first one we look at is the what? The alternate or alternating what? Angles. We look at alternate what? Angles. What some people call the Z angles. Why Z angle? Because we try to trace a Z out of the diagram. Everything has been explained and notes into details. So you can go and check it out. You have to check it out on what? www.matclass.com. Then you get a note from the Form 3 section. Then you do what? You follow. Everything has been explained here. So this is power line 1 and line what? Line 2. You get the point I'm making here. Good. When I decide to close this end, I join this end to this end. It will give me 2 regions. So I have region 2 and region 1. I can have this by closing this to help me do something. So let's go. Now, for alternate angles, this is what you keep in your head. Now, anytime you see parallel lines, anytime there are parallel lines in the question, these 3 properties, one of them must work. Anytime you see parallel lines, then we are going to look at the 3 things, and one of them must work. Hope you get a point I'm making here. Good. So let's go. So for alternate angles, I'll trace a Z. Tracing a Z from what? We say from a parallel line to the transversal to another parallel line. That gives us the what? The Z. Let's go again. From a parallel line, we move to what? To the transversal. We go to the transversal. Then we have another what? Parallel line in the opposite what? Direction. So we start from here, then we went there. So we get a Z. And once we get a Z, the acute angle, the acute and the acute angle here are what? Are equal. The acute angles of the Z we trace become what? Equal. Hope you get the point I'm making here. Are you sure? Good. So that means from alternating angles, we can say that C equals what? Equals F. From the diagram, if I trace. So, like I said, don't look at this. Now let's go. How do I say you should trace? Now let's go. Let's trace from a parallel line a parallel line to what? To another parallel line, to the transversal, then to this. You can see what I'm saying here. So we're going this direction, we trace here, we came down that same direction, then we went there. How to get a point? So from a parallel line, transversal to another parallel line. And once again, this time the obtuse angles will what? Equal. How do you get the what I'm tracing here? If you don't know how to do this thing, if you see the diagram, you don't know what to do. So in a parallel line, alternate angles, you try to trace a z. So there's a z that is traced this way and that is traced that way. How do we trace the z? Start from what? A parallel line to the transversal, the next parallel line. You get the point that go to this direction, the same direction which you are moving. Yeah, we're moving in this direction, so we go in that direction. You get the point that if you change the direction, you have a different thing. If you go this way, and you change the direction, you have a different thing. I don't change the direction. From here, there you follow your direction and you are fine. Hope you understand what I'm saying here. So therefore, from this we can say D is equal to what? Angle D is equal to angle E. Angle D is equal to angle E. And that's some alternate angles. When I'm solving the questions with you, I'll be hitting on them. But you have to sit down on this video, watch it critically to the end, get everything before we go to what? The solving of the question in our next video. Okay. So let's go. What do we have here? This is a summary of everything for you to write your work, your BECE. Good. So what do we have here? Then we are done with the alternate. So let's go to the next one, which is what? The corresponding. The corresponding angles. So you can see that alternate angles are equal. Same as corresponding angles. They are also equal. They are also equal. So how do we get corresponding angles? Now this is it. You could see that this line, the transversal, has given us a region 1 and a region 2. And we have line 1 and what? Line 2. When we look into region 2, I open my eyes into region 2, I can see that at this line 1, now I'm not here, so I'm focusing here. I mean, get what I'm saying? I'm focusing here. At this line 1, the angle on top here is what? Is B. If you come to line 2, the angle on top is what? Is F. How do you get the point I'm making here? How do you get the point I'm making? Again, I said we are looking at corresponding, meaning that when you listen to the vectors, top must go with top, down must go with down. That's when we correspond. So boss on top, this one down, that one down. But how do we get to know? The transversal has given us region 1 and region 2. In region 2, we have line 1 and line 2. At line 1, there's an angle at the top there. Take your angle. You come here, this one to there. So we correspond. Therefore, the angle F is equal to angle what? B. And this is what? Corresponding angle. So we say B is equal to what? F. Corresponding. Once again, the down ones to correspond. So down will go with down. This I'm getting from region 2. When you understand, you should be able to write the corresponding angles from region 1. Can you? Of course, you should be able to write it. Unless you don't understand, go back, play it again before you do it. You get the point I'm making here. So once again, I said we have what? We have line. We have region 1. We have line 1 and what? And line 2. At line 1, the angle on top is B. At line 2, the angle here is that. At line 1, the angle down there is what? D. At line 2, the angle down there is H. So we have what? We have D is also equal to what? H. So like I said, at this point, it should be easy. You should be able to know that in region 1, C must go with what? G. Then A will go with what? E. They correspond. The top here with the top there, the down there with the down there. Good. So you can say C equals what? G. And A equals what? E. How do you get this? So these are what? Corresponding angles. Then the last one, remember I said when you see parallel lines, one of these must work. So you have to know this. You want to see, try to trace your Z. Oh, it's not working. Try this, try that. If angles on a straight line, angles at a point, and you want to get it. I follow what I'm saying here. Good. Then we have the last one, which is the co-interior angles. And the reason why I had to close the co-interior angles, but they are what? They are supplementary. They are supplementary. That means they sum up to what? They will sum up to 180 degrees. They are not equal. So all the angles, the three angles, alternate angle, corresponding angles, are equal, but co-interior angles are supplementary. Therefore, they will sum up to what? 180. What are co-interior? Very simple. Once I've closed this and this, what angles are inside region 2? Very, very simple. What angles are inside region 2? This and these are inside region 2. That and that are inside region 1. So in this case, we'll have what? We'll have F plus D equals what? 180 degree. Then C plus E equals what? 180 degrees. Very, very simple. So you don't struggle yourself with this. No, take your time. What am I doing? Look at the tracing, trace that of Z. Now look at the corresponding top. We'll go with top. That is why the transversal is very important for you to know what a transversal is. Good. So this is about the power lines. Then we go to the triangles. We go to the next one, which is our what? It's about triangles. And for triangles, I always tell students, now, the most important thing one needs to know in the triangle are the types of triangles. Once you know the types of triangles, the properties becomes easy to apply. If you don't know the types of triangle there is or we have, then you will find it challenging working triangles. Because in the question, we can combine triangles and what? And power lines. So if such a question is combined for you, then people, if you don't know triangles and you know power lines, you cannot do this. I hope you understand what I'm saying here. So I said for triangles, that will be the last thing we're looking under this. For triangles, we need to know the three types of triangle there is, or the three types of triangles we have. And the three types of triangles are what? Are the equilateral triangles, the isosceles triangle, and the what? Scalene. And the next thing is that after knowing them, when I draw a triangle this way, the interpretation of the stroke. So when I say stroke, when I put this, that, and that, what this means is that the angle and the side, this and that are all equal. This is what I need you to know before we can now go into the properties. Once we understand this, it becomes easy. And this is a secret. Anytime there's a triangle, try interpret their strokes. That will help you to know what kind of triangle it is before you can even solve the question. If you don't know what kind of triangle it is, or you don't know even how to interpret the strokes, I'll show you what I mean by that. Good. And since the three sides are equal, then three angles are also what? Equal. This is what I say. If this thing, for instance, if this is 1 Ghana cedi and 1 Ghana cedi can buy A, then this 1 Ghana cedi should also be able to buy A, and that 1 Ghana should also be able to buy A. That means this one goes to 2 cedi, it can buy more than A, so this one can graduate to B. But we are dealing with the equilateral triangle, which is the first time we're looking at. For equilateral triangle, all the sides are what? Are equal. Everything is in the note. All the sides are equal, and all the angles are also what? Equal. That's what I meant by the fact that since this one stroke is facing A, then my one can also face A. Your one can also face what? A. How to get the point I'm making here? I hope you understand. So in this case, this is one thing we should know. Note, I've stated it there, that one way to master the triangles and the angles, triangles and the angles, is to know how to interpret the strokes. Now, the next one, if we have this triangle with two sides equal, this triangle with two sides equal, this side equals that side, and we have this. Now, this triangle has two sides equal, hence two angles will equal, and that triangle is called the isosceles triangle. So we have isosceles triangle. Hope you get the point I'm making here. Good. So for isosceles triangle, two sides are equal. And if two sides are equal, then two angles must be equal. This side is pointing towards this angle. So if this one is A, then your one stroke, right? Once again, I'm interpreting the stroke. That's what I'm saying here. Are you understanding this? I'm interpreting the stroke. So this stroke must face this. So this one gives me what? A. Then this one faces this. And because this one is 2, it can buy more than A. So we give it to a B. That tells you that two sides are equal and one side is different. I hope you understand what I'm saying here. If you don't know how to interpret the triangles, forget it. You cannot do this one. So it's very important for you to know how to do the interpretation of triangle. That's what I recommend. The first thing, you should know how to interpret or how to know the triangle before you now go to the properties. There are only two properties there. And once you know this, you can just work them out. And the third one, which has no side equals, so I have 1, 2, and what? And 3. So if this one is A and that one is B, then this one will graduate to what? C. You see, this is called what? The scalene triangle, or scalene. Let me just say scalene. Now, for scalene, all sides are different. And since all sides are different, all angles are also what? Different. How to get the point I'm making here? Good. So in this case, because I have one guy that I'm buying this, the 2 is buying B, 3 graduate to C, can buy C. This cannot buy that. This one is not pointing. That's why this one pointing is not 1. But since this could buy that, that's why it is pointing to A. Since this one is 1, that's why it's pointing to A. How do you get a point I'm making here? But this is 3 more than, so it will point to more than that. How do you get this? So these are the 3 types of triangles that we need to know before we can look at the 2 properties of what? Triangles. Triangles are only 2. Parallels are 3, but triangles have only what? 2. What are the properties? So this is what I need you to understand before I do this. Listen to this part carefully. Look at the thing. I said the only way we can solve this is to interpret the strokes. When the diagram is given to look at the strokes and try to interpret them. As I'm solving the question with you, I'll be showing more of that. So the properties, we are looking at 2 properties here. 2 properties of triangles. 2 properties of triangles. 1. The sum of angles in a triangle is what? Is 180. So if I have A, B, C, let's say we have this triangle, scalene triangle, then A plus B plus C should be equal to what? 180. If that be the case, then I can even find the angle here and say that A plus A should be equal to what? 180. That will give me 3 times of A equals what? 180. Therefore, A should be equal to 180 on what? On 3. Then A equals 60 what? Degrees. I found that. How do we get the point I'm making here? We can also say that then A plus B should be equal to 180. I'll get 2A plus B equals what? 180 degree. And this is what I have. I hope you understand the point I'm making here. So with the property, I can do this. Very, very easy. Very, very simple. So in any section A, the angle in an equilateral triangle is always what? 60 degree. If one angle is 60, the rest must be 60 in a triangle. I hope you get the point I'm making here. Good. So this is the first property, that the sum of what? Of angles in a triangle is equal to what? 180. And the second property, which most of you get confused, is very simple too. The second property says that the sum of interior angles, or 2 interior angles, equals an exterior. So let me try trace these ones out. Let me trace this one out, trace that one out, and trace this one out. Let's see the trick here. Let's say I have A, B, C. These are the angles I have. Then I have X, Y, and what? And Z. These are my exterior angles. Take note of what I'm doing here. These are my exterior angles. I said the sum of 2 opposite interior angles equals what? An exterior. This is the trick. You can see that this when I choose this interior angle and that interior angle, I can't choose an exterior from the side I chose the interior. Let me say it again. The exterior of the interior angles we are going to sum must not come from the interior angles we chose. The exterior angle that we are going to equate this sum, that's equated to the sum of this and this, must not be from those exterior, must be from the other side. That means when I choose B and A, I can't say it's equal to what? It's equal to Y, because if I say it's equal to Y, X will complain. Say, now you, but you can also say this. So to avoid, and if I give to Y, to X, Y also complain. To avoid this, I'll give to an external person. That means that the second part is saying that if we sum B plus A, that should be equal to what? Z. The sum of 2 interior angles equals an exterior, but this is how we choose the exterior. It should not be from sides where the interior angles or exterior angles closer to the interior angles. I hope this thing is clear. It's very, very clear. Now let's try. With that same thing, let's try. So B plus C, the sum of 2 interior angles must give an exterior. But we can't take X as the exterior, we can't take Y, because they are close to the angles we are choosing. Since we are choosing B plus C, then we can't say X, we can't say Z, but rather we'll say who? Y. I hope you get the point I'm making. Let me choose A plus, let's do this. A plus C. So we have A plus C. What do you think that will give me? A plus C. Would I choose Y? Would I choose Z? Y? I can't choose them. Why? Because they are externals from what? For exteriors from the side that I have what? I have chosen. So I'll go to the next other guy, and that gives me what? X. This is the second property of triangles. If you're able to apply this, oh, we can solve any angle question. Very simple for angles. What are the properties we look at? Once we go through all the properties, like we've done right now, then we solve the question. So when we meet again in our next video, we are going to solve more questions, at least 10 questions, or any question we solve, or any number of questions we solve within the time frame. So you can also go through. But in case you are solving question at angles and you don't get it, just comment in the comment section and we can explain them or reply you if you have any question. All the questions must be in the comment section so that we can reply you. Thank you very much for joining this class. Remember to subscribe and share to all the form threes. Most form threes need these angles. Share to them and also make them watch. Thank you very much for joining our channel.